Hello, and welcome to another episode of Unbottleneck, the podcast where we solve common marketing problems, particularly in digital marketing. And today we're bringing back one of our favorite guests, Scott Stouffer. Did I pronounce it right, Scott?
You
I hope
got
I
it.
did.
Yeah,
All
thanks.
right.
Glad to be on
And
here.
he is a search engineer. So we're going to get a little bit geeky, but we'll try to keep it at a level that everybody hopefully can understand and enjoy. And we're going to talk about something that's sort of fundamental to search. Before we get into how to optimize your content and how to get backlinks. Let's talk about how you would build an Evergreen Googlebot. If you were going to start over and say, hey, I need to build a search engine that's fair and it's organic, that isn't going to result in me getting sued by people because they feel like it's biased. So I'm really excited to talk about the topic today, and I know we have a lot to cover. So Scott, I'll let you take it away.
Sure.
How do we build an Evergreen Googlebot?
Yeah, I mean, I thought starting off talking about how a search engine is built. Sort of the first layer of that is understanding how do we gather the data, right? So it's the crawler. So the web crawler is the piece of software that is responsible for going out and it has a number of responsibilities. The primary responsibility obviously is to gather the data and be able to sort that data in your own database. There's a lot of crawlers out there that you can obtain today, as opposed to maybe 15 years ago when we started this. So if you're not a coder, you can always grab one of those crawlers and use those. There's a lot of different programs that can do crawling in the background. I wanted to give you just sort of like an overview of what a real search engine crawler is going to look like today in 2022, and just have the ability to understand as an SEO person what's actually happening in a crawler and how that can affect some of the things you do with SEO. And so it's just one of those perspectives that you don't normally get to see.
I love it. I'm
So
stoked. I'm
yeah,
stoked.
I think the first thing to kind of focus in on is just the beginning of crawlers, and that was obviously a crawler that was invented by Google called Backrub. So if you remember Backrub, I think it was in about 1996. Larry Page, built this crawler. They called it Backrub.
While he was still
Back
at
then, I
Stanford,
think,
right?
that was at Stanford. He was doing his thesis, and that was approximately 10 million web pages, I think, at the time, which was a lot, given the hardware. At the time, only two other major players had tackled the changes and of building a scalable crawler infrastructure, and that would be Alta Vista and Excite.
Right.
So, Larry Page and Sergey Brin were sort of the next two to discover how complicated that a project like that was. And, of course, my story starts a few years later, still, way before open source libraries and generic SaaS-based crawler offerings that there are today. And so one of the major things that you deal with as a search engineer is just the sheer scale of things, right? So back when we started this, we didn't have AWS. We didn't have all the cloud computing that's available today.
So
So a lot of
packets
it,
of information had to travel all over the place instead of getting a cached version of it on your nearest cloud web server.
yeah, and it's and you can imagine like the ability to code was not sufficient enough to build a crawler. You had to have hardware experience as well. You needed to have a hardware guy on the team at least, preferably a whole team of hardware specialists to tackle this. I remember I don't know if the image is somewhere. I think it might be on the Ask the Search Engineer site, but there's an image of us and in one of our houses that we had procured to basically put all these servers in. And so we had like rooms full of servers. We had electricians out almost weekly, upgrading all of our electric. We had multiple investments in air conditioning units, because just the amount of heat, basically creating our own data center. And that's what you sort of had to do back then.
Makeshift data center. I love it.
I think
No
at
raised
one point,
floors, no, yeah.
yeah, I mean, I think at one point, Larry at Stanford, I think when they finally kind of clobbered it all together and plugged it into Stanford's bandwidth, I think it was
Mhm.
taking down about a half of Stanford's bandwidth. So not only is it just the sheer scale of the hardware, but it's also just the sheer scale of bandwidth that's required to do this. And obviously, if you want to do a crawler like Google, you've got to crawl everything, right? It's not just you don't get to pick and choose like a different type of crawler might be. And so uh, so one of the main strategies that we had when we built our crawler is we weren't, first of all, we weren't building a crawler to compete with Google. We were building a crawler to understand what the crawler was doing. So
And we're talking
essentially, we're
about
building our
Market
own
Brew, right?
crawler. Yeah. And so so this is at Market Brew, and Market Brew's crawler. We came up with some really interesting ways to pick off subsets of the internet and be able to emulate or statistically get close to what was happening on the real thing. So that enabled us to avoid the sheer scale of hardware. We didn't have to be putting in 10, $20 million into the hardware before we even stepped out of the gate. We were able to kind of ramp up over time. So let me just go. We'll step back here and just talk about sort of the beginning of a crawler as you're building this crawler. The first thing you have to do is really understand what kind of content that you're going to crawl. So, right. So the first thing you have to figure out is am I going to be crawling just HTML pages? Am I crawling all my CSS
JPEG,
files? Do
yes.
I am I executing all the JavaScript files? What about XML files or JSON files or all kinds of different files that you're going to come across as a crawler? So that's the first thing you have to do is just sort of understand what content you're going to actually acquire. Another thing is like how many bytes that you have to crawl, right? So that sounds very trivial, but like there are sites and landing pages that go on for uh, megabytes, right? Like just continuously. There's the infinite scroll. There's a lot of different situations where you could get into a situation where a very tiny amount of pages on the internet cause a large amount of processing because you don't have that limit. So it's really about setting limits in the beginning, just so your
There used to
crawler
be a gauge
can.
for that, wasn't there? Scott, at one point in Search Console, there was this gauge that you could set to say how fast you wanted Googlebot to crawl back in the day.
Yeah. And so it's always sort of, if you think about it from a search engineer's perspective, you're always setting limits so that your crawler can sort of stay within the bounds of what is sort of normal. We always talk about the Pareto principle, the 80-20 principle, right? So it really is in this case with crawling is that you're 20% of the pages, and I would say it's even less than this, but it's like 5% of the pages on the internet cause sort of like all the headaches in the search engine world. And so it took with Market Brew, it probably took over 8 years before our crawler really stabilized and we weren't running into new edge cases. And even today we'll run into edge cases and it's almost like we have to do a double take. It's like, wait a minute, we've crawled how many pages, like trillions and trillions of pages and multiple times, and now all of a sudden this one page is giving us a problem, and it's usually because of some new JavaScript compiler, new JavaScript
Oh,
library,
there's
or
React now
something that
and single page
some non SEO
applications.
developer decided to put in
Uh,
into the work. So limits there are really important. You have to consider also like redirects, right? So when you're crawling redirects, this goes back to the SEOs that aren't coders here listening to this. It really does matter. You can't just be thinking, well, the crawler is just going to do everything for me, even though most modern crawlers, sort of try to attempt to do that. Most of the time, you have to worry about, like for instance, a 301 redirect loop, right? So how many times can a 301 redirect happen before you stop it, right?
right.
And this is simple. If you think about it, you might just say, well, just you just continue it until it's done, right? But there are situations where you get into a loop where 301 redirects happen. This happens a lot with when sites are redirecting HTTP to HTTPS, and
Dub
then
dub dub, no
uh,
dub dub dub,
and then
trailing
you end
flag,
up getting
no
this,
trailing
yeah,
flag.
exactly. And so you end up with this like recursive logic that continuously keeps you in this loop. So you have to find things like that, where you have to make sure that the crawler, the goal is really is you're trying to make sure that the crawler doesn't get stuck, right, on one specific part of the internet or one specific page or site. And so that's sort of what the limits do. And then also like, how long should you wait, right? So back in the day, it was just simply the server response time. But today, you and we'll get into this shortly here, where we get to talk about the Evergreen Googlebot that you can create. But a lot of this gets down to setting timeout limits on how fast that JavaScript is parsing on the page. So you load the content, and then there's a period of time between the content being loaded in your renderer and actually being executed, and the DOM being manipulated accordingly.
I
So there's
recall I
a
recall that being something that was brought up. I think it was just a couple of years ago, maybe even within the last year or so, where Google had mentioned, "Hey, we can crawl JavaScript now, and the way that we're going to do it is we're going to crawl the page. We're going to to process all this JavaScript, and then we're going to come back after we've sort of rendered and created a version of what the user will see, and then we'll crawl that page." After we've already
correct.
executed all those JavaScripts to see if we can emulate as close as possible to what the actual visitor is going to see in their browser. Okay.
Yeah, and this is exactly what we did back in the early days. So we actually were pretty confident that we were the second JavaScript rendering engine that
Nice.
was built after Google. I think we beat Microsoft on this. This is before Bing was doing the JavaScript
Yeah,
rendering.
that's amazing.
Back in the day, Marker Brew was called SEO Engine, and in 2012, and we had built our own sort of home-built JavaScript rendering engine. So this was really interesting. There was a period of time before pre-render.io, where the sites where you would be creating these escaped fragments and these static versions of this of JavaScript pages, because the crawlers couldn't understand what was happening with JavaScript. So
Yeah.
solutions like pre-render.io would come along, and pre-render.io would take your convoluted JavaScript that's running, and it would just run it through a rendering engine and spit out what the static HTML should be.
Yeah.
And so back then, what we would do is we would crawl the content, we would store that content, and then we would have a second process, just like you had mentioned, Google saying, where we would take that and run it through a rendering engine, and then sort of crawl that version after that. And you can detect things. The reason why we do that twice is that we would detect things like cloaked links and
Yeah.
cloaked content and stuff that
Affiliate
JavaScript
marketers,
was,
you sneaky affiliate marketers,
yeah, all that
watch
stuff.
out. These crawlers can figure what you're doing out, and they definitely don't want you blocking your JavaScripts or style sheets, because that's to me that's like a transparency issue. So
Yeah,
you've got the crawl control, and then we've got the process of trying to crawl a page after it's been after all the JavaScripts and style sheets have been rendered,
yeah,
and
and
then
so this became horrifically hard to maintain,
mm,
because we were literally maintaining a JavaScript rendering engine on top of our crawler, and having all these different various solutions like prerender.io came along shortly after. Maybe I don't want to date it, but shortly after that time frame, and so sites that were having a really bad problem with rendering their pages in with the JavaScript technology they were using, they would use prerender.io. And so, of course, in our crawler, we would have this flag that says this is a pre-render site. It was just a mess, right? So, that eventually, we grew out of that eventually to use the Chrome headless. And so Chrome headless is something that anybody can download, and it's basically just Chrome without a UI, and allows you to sort of through an API crawl a site. And basically what this gives us is the ability to constantly update to the latest Chrome version and the Blink rendering engine that sits neatly inside of that. And
mhm.
so that sort of all that processing and coding for a home built JavaScript rendering engine just sort of went out the window in lieu of just using the what you see in Chrome.
Right.
And so that's been a huge major improvement over the past few years, just the ability to tap into Chrome headless. We use some tools to actually allow us to do some really cool things with this now. So we can
Sure.
access the networking tools on Chrome, just like when you hit F12 on Chrome and you see the dev tools. We can do all kinds of things programmatically. So, for instance, we can emulate user agents. We can add our own JavaScript before loading. You may ask why that is. Well, this thing came out called recently came out called Core Web Vitals.
You.
So there's a Web Vitals script that webmasters can use to add to their site, and that allows them to sort of measure actual in the field measurements for users, whether or not they're getting good Core Web Vital metrics. But that code has to be on the page for it to actually load, for actually a user experience to load. Otherwise, you can go to Google's own tools and get sort of like the non in the field metrics. It's basically
Yeah, and then
just
they're
telling,
different every time. So
yeah,
yeah, I like
and
the idea of
it's a
doing it
mess.
native.
And so what we did is early on we came up with an idea of, well, why don't we inject this Web Vitals script on the page as we crawl it, and we'll do it the same way for every single page that we crawl, and that sort of gives us sort of a baseline because we're doing it the same way to every single page. And then we actually execute, it gets executed as if the site had put that script on there to measure Core Web Vitals.
Mhm.
And then, of course, one of the great things about that is that your crawler can then, at scale, measure Core Web Vitals for millions of pages, right? They don't have to have that script on the page, because now we can inject that script on the page as if it was already there. So these tools that came along later on were really, really helpful in sort of emulating what Google wants to do. Google creates a lot of specific metrics and specific ways it does things. So this, being the dominant search engine in the world, kind of was a nice way to go technically.
Right. And
So
it's nice that they
that's
have transparency too, Scott. It's nice that when you see a post that says HTTPS is going to be a ranking signal, and you see mobile page speed as a ranking signal, when you see those, in Google and even in Bing blog posts, you're like, thank you for being transparent and telling us what's important to you, because now you're giving us guidelines, and having guidelines helps keep us from going to the dark side of SEO and doing things we shouldn't be doing unknowingly or knowingly.
yeah.
So I think it's great that they're being more transparent and saying this is what we're looking for, because it gives us something to work toward.
Absolutely, and so we're talking about we were initially talking about setting limits and bounds on the crawler. We're also now talking about the ability to run these complicated JavaScript commands when we load the page, so we understand exactly what the user is seeing and obviously what Google is seeing. Then we get into performance considerations, right? So we've got to be able to set sort of limits on how many 403s are we going to allow, right? So if you're crawling a site and all of a sudden you start getting a lot of 403s, it's going to be
403, for those people listening, is basically a forbidden
right.
error code. So it's not just not found; it's saying um, you're not allowed to come to my page, basically.
Right. And that typically will get triggered by many different things.
Yeah.
If you have a non polite bot that is crawling too fast, or maybe the server, a lot of the servers are very aggressive today, and
Mhm.
they will literally just anything that looks non-human, it will just stop totally. Um, and so there's different things that you want to do in your crawler, because you don't want to, again, you don't want to get stuck on parts of the internet where it's not going to scale, right? Because you're going to have like that 5% of those pages taking up all the time. So you're just hitting basically over and over again. You have to have timeout limits on the crawl. So if you start crawling a site and their server is having a performance issue, you don't want your servers or your queue to slow down. You simply want to just say, okay, well, there's something wrong with this site. We put it into a special queue and move on with the rest of the site.
Which,
This
as a
is
business owner,
particularly
you don't want to happen. You want crawlers
right.
to be able to go in, get what they need, and get out. You don't want them to have to say, "Oh, well, I'll come back later." Especially if you have new content. Maybe you've got news that you want shared, and that news needs to be there like within seconds of being published. If you've got side errors and the crawlers are seeing 403s, your news post is probably going to show up a day late. You know.
Yeah. So yeah, that's absolutely the takeaway for SEO is that when you have any kind of technical issues, you can rest assured that like search engineers who are building these crawlers are going to make sure that if we do detect certain issues like this, a lot of times your site will get kicked into sort of a different queue and processed at a different time, right? It's sort of like taking somebody out of the line and saying, come over here, we have to wand you security wise, right? So it's basically like you get a different set of rules that get applied. So timeout limits, 403 limits. We got to do timeout limits on the scripts themselves, right? So in that JavaScript rendering engine, even if when we use the Chrome headless now today, we still have to put a limit on the JavaScript processing, because you can load a page and it's JavaScript. We have no control over that, right? I can write a JavaScript program that loops over a million times before it releases the JavaScript function or method. And so the search engineer has to always make sure that you keep sort of a box of limits, so that you don't have that edge case kind of rip apart your entire process.
Right.
Then we get into like the performance and accuracy. One of the things that we had to invent at Market Brew being a much smaller company than Google, we had to have the ability to crawl at the scale of Google, but without sort of the cost of the hardware of Google. So this perplexed us for many, many years, but we've eventually figured it out over time, and we were able to use sort of a neural net crawler that was self-learning, right? So what I mean by that is that we would go out and a lot of times our modeling tools are going to be modeling specific areas of the internet, right? So with our crawlers, we decided, well, we don't need to crawl the entire internet. And by the way, if you're going to be writing a crawler for backlinks like Ahrefs or anybody who has a backlink index, you kind of do have to crawl the whole internet. In fact, we had early 2013, I think we had a thing called the link neighborhood. This is before Ahrefs, and this is just basically, I think we had the Yahoo's link index
Majestic,
and Sitemoz's
there's
and Majestic.
SEMrush, right? There's all
Right.
these different tools. Yeah.
Yeah. And so Market Brew, we saw this as sort of a going commodity, right? Everybody was going to have a backlink index, or not everybody, but it was going to turn into a commodity. And so we decided to ditch the link neighborhood. But with the link neighborhood, you have to crawl the whole site. So you're basically taking a lot of the limits and cutting the limits down, right? So like the limits become tighter because you want faster crawling, right? So anything that's outside the bounds of what is normal, it's going to be even more limited with that. So it depends on, performance wise, it depends on what you're trying to do. But from our perspective, we were building statistical models so we could relax some of those limits. It wasn't going to be like a full on, we need to crawl the whole internet. But to do this, you have to solve a couple problems, right? So you have to understand the accuracy of your models or your graph that you're building. And so the crawlers would actually crawl a site and analyze that site. And then the next time around, it would try to limit the pages that it crawled the next time. So it's always constantly trying to find what is the best statistical sample of that part of the internet. So instead of crawling all 10 million pages on like Walmart or something like that, our crawler might find out that it only needs 500 pages to build a statistical model that's 0.0001% accuracy less than doing all 10 million pages. And so there's a limit where
templates in the right. So for
Yeah.
product detail pages and categories, for example, I don't need every
don't need every single
refinement
permutation.
of every
Yes.
product URL, right?
So we would do some really cool tricks with that and come to have a very sophisticated crawler that not only incorporated all this new JavaScript technology, but also was able to crawl in a fraction of the time. Right? We most crawlers out there that you can rent or buy, it's a brute force attack, right? You're just brute forcing. We're going to crawl 10 million pages and get all the data if that's what you want to do. But in our case,
there's deep crawl, there's on crawl, there's write, and you kick a thing off and it's like
Screaming Frog 2, another one. Yeah, and it really did become like a sort of a commodity where it's just a matter of what you're trying to do, and sort of the devil's in the details, right? So when typically what you're doing when you're renting or using a crawler is you're trying to solve a particular problem,
Hmm.
and that crawler, because it's a generic crawler, is sort of unable to solve your specific particular thing that you're trying to do, whether that's pull out specific data and process that internally, pre or post process it. So a lot of times the crawler and the way that the solution that you're trying to develop are interconnected. And so like in our case right here, we're building statistical models at Market Brew. We made our crawler specifically focused on doing what the same amount of work that Google's crawlers do, but in a fraction of the time, because we didn't want to wait, to be able to have to crawl every single page to get the answer. And so, but when you do that, you run into other issues like if you truncate the graph, right? So if you take a web graph and you truncate it, you're left with what? You're left with a bunch of dangling nodes, right?
Right.
Nodes that they link to other pages, but they're not there in the graph, right? We sort of truncated them. So what do you do with that? And you can go back to the original PageRank patent and their discussion of how do you deal with dangling nodes. There's a nice way to sort of use that in the calculation when you're sort of understanding the eigenvector matrix of that web graph.
Sure.
So there's a lot of stuff that went into that. It took many years to kind of do that. So depending on what kind of crawler you're building, you can cut corners, or you can make it specialized in a certain way. So that's one consideration that you have to look at. The reachability is also another consideration, right? So a lot of sites will just completely block crawlers,
Hmm.
whether that's for competitive reasons
Sure.
or just privacy. If you're in the travel
So
industry,
this
you're
allow
obviously
all, but
protecting
allow
scrapers from,
Googlebot and Slurp. Yep, I've seen that.
yeah.
Yeah.
And so obviously you have to have, in a case of, if you really want to have a scalable crawler, you've got to have some sort of proxy network in the case where you want to be able to simulate, multiple users and not just have sort of a naked signature that I'm a crawler. And so the ability to have like a proxy network, that's one of the things that you need to look at. Also, the ability to throttle your crawler. So if you detect that a site is, very slow, or if it's uh, returning 403s, one of the first things our crawlers will do is try to slow up the crawl just to make sure that we're not putting any undue stress on that server. I think we have an average of like 3,000 3 seconds to in between crawls when we're crawling any subdomain. So any subdomain, kind of, it checks to see if it's crawled at any time sooner, and it will add a throttle timeout there.
Yeah, isn't there a way
So
for
there's,
web servers to detect whether you're really Googlebot or if you're trying to crawl as Googlebot?
yeah, I mean, there's some very sophisticated software today that can pretty reliably detect whether it's a bot or a human, and obviously can detect like a Google bot. You can spoof the usernames.
Yeah.
You can't spoof. You really can't spoof the IP addresses. So there's different signatures on a crawl where you can kind of ascertain whether or not it's a bot or a human. It's
Right.
really up to the user of the server to determine how aggressive or not aggressive that is going to be. Obviously, the more aggressive you tune that up, the less scrapers are going to crawl your site, but the more issues you may have with searchability and
Mhm.
crawlability just with the legitimate crawlers. Like a lot of clients that come to use Market Brew technology, they'll come on board and we give them special user agents, or we can even whitelist their servers that we set up for them to do these models so that,
That's the way one of our clients has to do it because they've
yeah,
blocked any kind of crawler that we've tried to run. So we have to give them specific IP addresses
yeah,
to add to their allow list, right? We're trying to be more politically correct these days, right?
yeah.
But yeah, and it's a pain because they'll remove it as soon as the crawl's done. They'll keep nagging us, "Hey, is the crawl done? Is the crawl done?" Like, yeah, it's done. Okay, great. They remove the IPs. So talk about like
It depends
security.
on what kind of site you are. I mean, if you're a site that's selling data, then obviously you got to be
This is a
on
restaurant,
lockdown,
Graham.
right?
This
Because
is
I
crazy.
mean,
It's a yeah.
anybody can write a scraper, scrape the data, and there's all your IP. So I
Yeah.
totally understand it. On that same line, we would be missed by not talking about robots.txt. So
Yes.
obviously using the meta robots and the robots.txt file, I think is something that just goes without saying. When you're building a crawler, you've got to have a robust robots parser. So you
Mhm.
have to understand exactly what the how to be polite as a search engine crawler. So that's very important. Is you want to make sure that uh, you're crawling fast enough, but you're also you're obeying what the sort of the rules of being a good citizen on the internet.
So if the robots file says disallow a folder called private, you don't want to crawl the private folder because it's rude and it's something that they don't wish to have indexed. Right.
Yeah, and also got to go back to the what's the crawler doing, what's it for, and so the crawler that we build at Market Brew, we're building statistical models of Google basically. So we want to know exactly what Google is going to look at, and so we have to parse all the directives, even if they're conflicting directives in robots.txt. What do you do if two things are conflicting or ambiguous? And so you have to sort of understand what the what the protocol is, but then also how does Google approach that protocol? Because even in the definition of that, there can be ambiguities and stuff like that. So it's very a lot more complex than you would think than just using sort of like a robots
I've
reader or something like that.
Scott, I've heard that
Um,
it's required now for a lot of different search engines are requiring a robots file if you want to be crawled and indexed. I'm hearing a lot of rumors about that, and then I'm also hearing, and this has kind of been going on for a while, that search engines really don't want you using the robots txt to block folders. That they prefer you just put a no index in the meta tag on the pages themselves, so that they can
yeah.
crawl everything and then only index what you've declared you want indexed in the page itself. Is there some background on that? Is it just to prevent all the affiliate marketers from doing the cloaking and stuff they're doing, or what was the reasoning behind Google, basically saying please don't you know block anything using robots txt instead,
Well,
use
yeah.
the page.
So obviously this is all conjecture. I can just guess at what the reasons would be being building my own search engine.
Mhm.
But I think there's some altruism to this. I think if you look at, and a lot of people don't understand like link flow theory or link flow distribution theory, which is just basically understanding the graph of the web and understanding the citation structure in between it and how certain links are more powerful than other links and how that all plays into the
The catalyst
overall.
to determining importance. I love it.
Yeah, and so when you look at a link flow distribution, essentially the distribution of we could just start with the internal link flow distribution of a site, right? So where does that link flow go once it comes to the subdomain? Which pages does it go?
Yeah.
Effectively, yeah, when you design a site and you link up all the pages on the site, you are telling the search engine these pages are more important than these pages, and so on and so forth. So we're talking about sort of the distribution of ranking power that goes to all these pages. And when you look at that distribution, it turns out that when you use a meta robots no index follow, right, which is typically what you're trying to do, that the or if you're using a robots.txt file, a lot of times when you're blocking those pages from a robots.txt file, you can actually end up with a node that is existing with an existing amount of ranking power in your site, but
Mhm.
does not get indexed, right? It actually uh, doesn't become a revenue producing page for you as a site owner.
Right.
And so you really want to focus on the meta tags primarily because you don't run into so many of those problems with a robot.txt. So there's actually a real reason technically why they don't want to. They would rather have you put the tags on the page.
Mhm.
And so yeah, I think I want to, as a search engineer, I want to believe that's the real reason. There could be other reasons, but there's an actual real reason to not use robot.txt. If you don't know what you're doing, you can really kind of we call it internal link loss. Essentially, you've
Yeah.
got all the citation structure coming to your site, but you have certain pages that are hogging up all that structure. Think of it like your privacy page or a terms of service page, right?
Yep.
These are good examples of internal link loss where you
Because they're on every
have a
page,
lot of
linking
link
on
flow
every
going to
page.
these pages just because you have them linked from every single page.
Yep.
Yet those are not going to return you any revenue, right? Those pages are not going to. There's a million privacy policy pages on the internet. Yours is not going to be the one that comes up. And so these pages that get kind of hog up all this link flow, whether it's because they have the link flow and they're excluding it from being indexed, or it's just simply a page that it's indexed but it's not going to be unique enough to rank on its own, but it's taking all the link flow from the pages.
Right.
So these are all things that you would want to look at when we're talking about robots and how, do we exclude certain pages. So
Sure.
I want to say that it sort of deals with that. Yeah. So I
I
mean,
can't imagine why anyone wouldn't just put user agent everything, disallow nothing, and then sitemap and a path to where the XML is, and just leave it at that. I feel like there's so many sites that continuously put things in their robots txt, and you really don't need to. I don't think. I mean, I
I
can't.
think I view it as like everything else, right? Like if you're an expert, you can tell you're talking to an expert because they don't have to explain too much, right?
Right.
Like it's very easy. The more easy somebody explains something, the more easy it sounds, the more likely that person's an expert. It's the same thing with designing all these exclusions and stuff like that. The best thing to do is just get your link graph correct. You don't need to be adding no follows. You don't need to be adding robots.txt files. Just get the link flow correct.
Hmm.
If you don't want a page to suck up all the link flow, then go fix your internal linking. You literally can do things where it looks just fine on the UI perspective, but from a search engine's perspective, you've optimized it so that only the pages that are going to be revenue pages get most of the link flow internally. So that's the best way to do it, absolutely. And it's sort of the same reason. The clean organic way is really the best way, but you have to know what you're doing when you do that. I think the robot stuff and the no follow, those are the easy way out, right? You see something wrong and I'll just throw a little tag on it and everything will be fixed. So anyways, go back to sort of the building the crawler. We get into accuracy issues. So we deal with things like redirects, canonicals, hreflangs, what we call preferred pages. I'll talk about that in a moment. Or orphan pages, right? So our crawler, you have to determine how aggressive your crawler is going to be, but our crawler will actually pull out HTML URLs from the HTML that may not actually be being linked to. And this actually happens a lot with JavaScript,
Yeah, as I
where
say,
you'll
JavaScript
get a
on
lot
the
of like
href tag. Yeah.
in comments, you'll see the URL and it gets used in on click event or something like that. But
Or drop down.
uh,
It's a drop down list of URLs, and it doesn't contain the href tag. I've seen that.
Correct. Yeah. So we have to do a lot of things with that, understanding how these orphan pages fit into the overall crawling strategy. When we talked about canonicals and redirects, those all have to be addressed. When you have a canonical, obviously you're redirecting link flow through to the canonical. And also when you're crawling, you have to kind of understand, hey, have I crawled this page before? Is it, in your budget, when you're building a statistical model like our crawler does, you're basically worried about, what's the actual canonical page of this page, and, have we crawled it yet? And if you've crawled one of the pages that are canonicalized to that page, you have to make sure that that canonical page is also being crawled and scored and everything. And so there's this butterfly effect that you deal with to make sure that the accuracy of the model or that link graph or page graph is correct.
I remember Amazon
Um,
working through that the way that their old site structure was, and you wouldn't find a href link to the canonical URL that they wanted in Google's index.
yep.
And because the way that the system was set up was with all refinements and search queries and stuff, and
Yeah.
when they finally figured it out. I mean, I remember this like massive spike in how they were able to grow their traffic almost overnight and come out of what was a pretty nasty financial deficit back then. So
Yep.
pretty big win to have fixed just that whole URL schema.
Yeah. And then we talk about performance considerations, right? We talked about uh, the obvious performance issues where we talk about setting limits and making sure that the crawler doesn't get stuck on things. But then you deal with actual performance issues of your infrastructure, right? So there, it starts with a database, right? So Marker Brew runs on Postgres, but there's many different types of databases out there. Google invented a thing called Bigtable to address the massive scaling that they had to take on. So with your database, you have to understand, when you're recrawling sites, right, and you've got millions of these links and pages and all these different entities that you're storing in a database, there's things that pop up where there are actual limits to how fast you can push data into a database. In fact, when we started Marker Brew in 2007, we had one of our first big clients got signed, and we quadrupled our traffic overnight. And something got mixed up, the communication, and I wasn't aware of what was happening. And here I am building out our first, kind of alpha product, going into beta.
And the database crashed.
Yeah, the database, we were using MySQL.
Oh, geez.
And MySQL is just fine. It's a great database, but it turns out there's a massive insert limit on MySQL that back then we ran into.
Old CMS system. So yeah, and you
Yeah.
have to change the settings. Change it to 32. Change it to 64.
So
Change
we
it to
ended up
128.
within a 2-week period. We actually, I pretty much didn't sleep for 2 weeks, and I rewrote the entire RDMS system from MySQL to Postgres. Simply because there was this sort of the insert bottleneck for MySQL. So you deal with things like that. We ended up solving some of that with the way that we do with link parsing. So every link that we crawl, obviously most of those links are already on the page that we crawled before. So this is a new update to the page. So we don't want to delete all those links out of our database. We simply want to find those links and update the ones that we need to. And that saves us a lot of processing because we're not deleting every link out of the database. It's got to write a transaction lock on that and a separate table that it's got to write out to. And then you insert all the links again. And that's a very inefficient way to do things. So we wrote our own link matching algorithms. We have a collision detection and resolution subsystem called the Link Discoverer and the Link Collider. So there's all kinds of crazy things that go into sort of the performance of getting the data into the database, right? So we're kind of merging the crawler and the storing and indexing part of it. And we'll talk about that in a later podcast. But all of these things here are crucial into making sure that the single-threaded crawler is fast enough so that it can, shove the data that it's crawling as fast as it's crawling. It can push it into the database. So again, you really the trick about building a search engine or building a crawler is that you are dealing with that Pareto principle, right? So it's you can be running for many years, and all of a sudden you run into all these edge cases, and usually it's just one or two edge cases that you run into. But the example would be like just recently Pizza Hut. If you go visit the pizzahut.com site, you'll find this thing called escaped fragments, right? And back in the day, escaped fragments were just simply anchors, right? Like you have a URL, you put a pound sign, and you put a little anchor next to that. Yep. And that's not a unique URL, right? The anchor was sort of stripped off historically from Google.
Web analytics too.
Right. And so now fast forward, you got all these new JavaScript regimes where they're actually using these escape fragments. Escape means basically you have this exclamation point and then the pound sign. That's called the escaped fragment, the fragment being the pound sign part of it. And it turns out that now with a lot of these interfaces, when you write when you write a crawler, you've got to determine, do these escape fragments actually change the content on this page? And if so, then all of a sudden you have to start considering the escape fragments as part of a unique URL. Right. So there's all these edge cases that can have these rippling effects throughout the entire system. You think you have it exactly, you have a URL defined exactly the way it's going to be, and that's the end of the story. And then 10, 12 years later, you have escape fragments leaking into URLs. So all kinds of things that you have to worry about. You have to worry about understanding parsing images, right? So when you're crawling, you have to understand how am I going to, what am I going to do with this? And a lot of this is based off of what you're trying to process. So in Market Brew, we look at the bytes in the image. We look at the image size. We want to know the image size primarily because if it's a link, we want to know that that's a link signal, right? So how big are the images? Where is that image on in the DOM on the screen? So all these kind of determine how powerful or not powerful links may be. And obviously, some of the convolutional neural networks today can look at a picture and give you a sort of an alt text automatically.
Right.
So that's another thing that our crawlers going to be looking at is the ability to do stuff like that with images.
Alts
You have
and
to worry about
captions and yep, the whole
yeah, you
thing.
have to worry about like caching CSS files, right? Because you don't want to be crawling that CSS file over and over and over again. So you have to have servers that will maintain, a cache version of CSS on specific sites, and all the stuff that gets loaded every single time. You don't want to be redoing that as much as possible. So you'll have you'll have your L1 cache and L2 cache, and there's all these like layers of caches that you'll have throughout the entire site or your architecture
Right.
to make that web crawler run as fast as possible. So that's sort of the idea when you're approaching building a crawler.
Mhm.
Uh, those are the types of things that you have to sort of figure out. What is it going to do? What's the data it's going to operate on? Again, in Market Brew, we build statistical samplings of this of the web graph. So we actually break up the internet into what we call shards, SHARDS, and so these are basically delineated, pieces of the internet that gets cut up into different pieces and put on different servers in the Market Brew architecture. So we basically each server farm is looking at a different part of the internet, and that's how we sort of break it up and are able to scale that up to as large as we want. So
Right.
there's all kinds of sort of architecture things that you have to worry about from an SEO perspective. I think the big takeaways here are just understanding that the crawlers are not magical, right? Like they're not going to just solve all your problems. So the best thing you can do as an SEO is not get into the situation where you're asking yourself, well, will the crawler be okay with this, right? Because if you're asking that question, you're trying to do something that's not standard or not nominal. And so I would say just as an SEO, try to stay within the bounds of what is normal. If you are working with a new technology or a new like JavaScript library, be very, very careful on your rollout. Make sure it's put through user acceptance testing, run some sort of model or some sort of SEO tool on it to make sure that it's able to crawl the way you think it will. I think that's probably the main goal of our commercial product at Market Brew, which is we want to make that as true as possible. So our goal is when you're crawling using the Brew bot, basically, we want that bot to emulate exactly what we think the Googlebot would be doing, and
Right.
that's primarily the only purpose of that is so that the user of our technology can actually understand exactly what's happening with Googlebot. So
Yeah, and
from an
have
SEO's
confidence
perspective, you got to
that you're
really
gonna get it. Yeah.
what's that?
That's and have confidence that the site is crawlable and indexable by
Yeah.
search engines like Google. Yeah.
So I think those are the things that kind of like outside of just using Chrome headless, which is a huge boon to all of this, was the ability to kind of not have a home built JavaScript rendering engine. It's all kind of sort of packaged up in there. Um, Outside of that, there's I think let's see, I think I counted 5,180 lines of code logic in our main crawler,
Oh
which
my
is actually very small if you think about it. It's the logic behind taking the content and putting it in our system
Mhm.
in a way that we can index and retrieve that. And later on, we'll talk about the scoring layer, right? The scoring layer is the sort of the next layer down,
Right.
where it's taking all the data that's been stored and we're going to act on it, right? We want to look at the data. We want to start running thousands of algorithms across it. And each algorithm is going to have its own way of looking at that data, but we have to prepare that data so that it's clean and it's uniformly distributed the same way across every single site. Because as we're looking at sites from a search engine's perspective, you always want to apply that same methodology equally across all the different sites. So that's the scoring layer. We'll get into that a little bit more. But do you have any questions, like from just an SEO perspective,
It just makes
about
me
the
want to
crawler?
go back to the days when we switched from tables to CSS layouts with CSS Zen Garden. There was just this time where we could create an HTML page that was 150, 200 rows of code max, super clean, very organized, one JavaScript, one style sheet that we would call, and then the metadata at the top. There was a time when HTML was simple, and I want to kind of go back to those days. And in some cases where search engines don't need to crawl certain types of content, maybe we put that on a subdomain and just block search engines altogether from all the processing things and functionality that isn't something we want indexed, and keep that marketing content, those upper funnel, lower funnel pages, just super lightweight and clean and easy without all the extra JavaScripts and the code that sort of bloats our site. Kind of want to go back to those days, but it feels impossible now because of the way that different systems need to interact with content and personalization and location targeting. There's just so many different things that we can do now functionality wise that I feel like the days of 150 row HTML pages, one combined JavaScript and one combined CSS, just isn't possible anymore. But search engines would crawl and navigate our sites like it was nothing back then. Our sites loaded in a fraction of a second, and now we've got a lot that we're trying to process and do and make happen that almost makes old school design obsolete. you know
Yeah, and I think with in the advent of what seems like every year there's a new JavaScript library.
yep.
I think you're always going to have situations where you have web designers and UI designers trying to push a certain technology without any kind of context of how does this play into the crawlability of a site.
Yep.
So you got to really
I
be
agree.
careful, as an SEO uh, professional or a website owner that's hired a professional. You really have to be careful with the SEO side of things when you're dealing with new technologies. So that's the only thing that I would say. Just disclaimer: new technology in itself is not a bad thing. Like, there's some amazing new JavaScript libraries that help pages load really quickly, and you're doing a lot of lazy loading. And so, you just have to be careful that I'm not trying to push people into getting a tool like Market Brew, but like you have to have some sort of tool that allows you to understand whether or not that technology can be crawled efficiently or not. And a lot of times you'll find things where parts of the page are just missing because maybe that page doesn't get loaded until there's a user interaction.
Hmm.
We do actually in our crawler, as part of the JavaScript rendering engine, we will simulate user clicks, just so you know. So we can do this, and just maybe this helps people understand that Google can do this, but you can simulate user interactivity. We have a library called Selenium that allows us to emulate anything we want. So it's actually originally written for user acceptance testing, unit testing, where you can just simulate a bunch of unit tests that where a user clicks on links or does something on the screen. You can make it basically a user do anything you want programmatically. And so we will do this for a number of reasons. One is, when you have links that don't have URLs, right? You have to click on that link to see where that URL actually goes.
Hmm.
And obviously, we wouldn't do that for every single link on a page, but we've got algorithms where if there's like 100 links on a page, none of them have URLs. We'll click on one of them to see the translation between what that URL becomes when the user clicks on it, and a lot of times we'll then use that and extrapolate that to all the other links. That's one of the ways that we do it. And then
One of the things
also
I like,
just
Scott, not to interrupt, but one of my favorite things is that that this engine was built by search engine engineers, where a lot of the other web crawler tools were built by developers that were trying to just create something that can throw some information in a database. Whereas Market Brew is genuinely, built by search engineers to understand how search engines are interacting, like you said, with the links and the content and the JavaScripts and the CSS, not just
Yeah, I mean
getting lots
it's an
of
SEO
URLs. Mhm.
specific crawler, right? So
Yeah,
we designed it in mind to be used by SEO professionals, not just a regular Google user. It's somebody who actually wants to see the inside of a search engine, how it's actually working in real time. So
love it.
um, yeah, so I think that's the major sort of overview of how to build a crawler. Obviously, it takes many, many years. I mentioned before, it took, I think, almost 8 years of running this crawler nonstop, trillions and trillions of links and billions of pages and we still were running into edge cases at that point. But it really took about 8 years for us to stabilize where it wasn't just like, nonstop, part of the crawler breaking and trying to, fix that edge case
Blowing up
here
server
and there.
CPUs and
So that's really,
yeah,
when you're building a crawler, I would say just like anything in machine in big data, is the more data that you have, the more crawls that you have under its belt, the more trustworthy it's going to be. It's one of those things where you just don't know what you're getting into until you get fully into it.
right.
um, as all the different things, you might have one edge case and it changes the entire approach of every single other page because of the way that it's just that logic that needs to be processed. So
You guys have built
um,
something amazing over there, Scott. I'm super impressed. I know looking at the insights in the back end is always exciting, and so that was basically the the what was it, the tapered down version of an evergreen search engine and how it's created. But there's obviously so many rabbit holes we could go down in every single part that you talked about, from nodes and databases and hardware. And there's so much that can happen with it. But at least for those people who are in, search engine optimization and thinking about a little bit about how search engines work, now you've got some context as to all the things that are behind it. And I can't wait to get into the scoring part of it when we get into that
that'll be
particular
fun.
episode. I know we have a few planned, but this has been amazing. Anything else you wanted to kind of throw out there before we wrap up?
Uh, yeah, but we'll get into the scoring layer next. It basically builds upon what we talked about today, and talks about like how does what is a scoring layer? People don't even understand like what is a layer, right? Why are we
Yeah,
talking layers? So we'll talk about like the overall arching structure. But like for instance, in 2012 ish, Google came out with caffeine, and
hmm,
that was literally the separation of the scoring layer from the crawling layer. They made a scoring methodology that was not completely tied to the crawling part of it,
God, I
and
thought that
sort
went
of
back to like 2009. I remember that.
2009 maybe, I don't
Yeah,
know.
God, that was
um,
forever ago.
yeah, and so the scoring layer is itself a sort of a separate entity today in modern search engines, and we'll go over how it takes all that crawling layer and all that data that gets stored and properly put in its place, and how we can take the scoring layer and start to build actual functionality out of a search engine, and we'll
Love it.
eventually get up to there's the query layer on top of that, where we are able to take in real time all the data that's been scored and use a user query comes in real time, and we need to instantly index and return a set of results based off of all that pre-processing in that scoring layer. So
I
we'll talk
can't
about it
wait.
a little bit later. But for the Evergreen Googlebot, that's the major considerations in building a crawler. Again, with Chrome headless today, you can, if you're a hacker, you can go out there and build your first crawler by just simply proxying sort of the Chrome headless engine, and sort of get started that way. You can look at Selenium. Selenium is a great API to use Chrome headless, and there's a lot of different supporting libraries that you can use to on top of that, all kinds of different
That's great.
HTML parsing and stuff like that. But yeah, we could sit here and talk for
Talk about the
for
details
weeks and weeks
forever.
on every little aspect of crawling it. There's the devil's truly in the details, but with something like Chrome Headless, it kind of solves a lot of things out of the box for
Yeah.
first timers. So if you're definitely looking at that, I would go
Google
with
it,
that.
check it out,
Yeah,
Chrome Headless, and
Chrome
then
Headless
Scott
and Selenium would be
and
a
Selenium.
good start. Yeah. All
Perfect.
right.
And then
Yeah.
until the next episode, that's a wrap for an Evergreen web crawler. And Scott, thanks as always. We'll see you on the next one.
All right. We'll see you soon.